Hello. This is how to structure classes for new engineering students, but this can also be used for just new college students in general. Okay. So, the main goal of an engineering student is to get your classes done as efficiently as possible. And this is assuming that, of course, that there's no schedule conflictions, but there will be. And so you have to realize that, these many factors are going to play a big role in how you will schedule your college courses throughout the 4-year program you're in. So the first step would be to build or use a flow chart. Or, obviously, many schools do provide them, but necessarily it might not be the best idea to use those flow charts because sometimes they go based on the degree requirements rather than what is best for you as a student. This is just the mechanical engineering flowchart we use at the University of New Orleans. It's the one I currently did. For example, you start with calculus, you have differential equations, which leads off into circuits, thermo, heat transfer, fluids, things like that. And you have the bottom section, with the more static side, dynamic sided. Here's electrical engineering at UNO, another example. Just the main difference is the second half, junior year, where you go into systems, probability, electronic systems, power systems, just a variety of things. And two, you really have to follow a basic structure built upon what is the necessities of your major. For example, it's just engineering courses in a nutshell, or just a basic side. You start off with math. Math is the most important part of an engineering major because these are the classes that, what engineering are built upon, the concepts they are based off of, and the programs that, you use to do this. So, you start off with math, and then you move up to the more basic engineering courses, which would be statics, dynamics, circuits, semiconductors, things like that. The classes that, that aren't as technical. Then you have the advanced classes, just fluid dynamics, some of the more intense heat transfer stuff. For electrical engineers, this might be, systems, probability and signals. Although I'm not an electrical engineer, I wouldn't know a lot about that. For chemical engineering, this might be, like building a reactor or whatever those classes are. I'm not too sure about chemical. Then you move up into the more, general side of science as a whole. Physics. Physics is more important than chemistry and comp sci, or, depending on your major. But, it's kind of grouped in that, not really engineering. These classes are kind of like prerequisites to the, engineering classes that you take. For example, chemistry would go to material sciences. Physics would be obviously, civil and mechanical, and engineering as a whole. And the comp sci, obviously, that's a bit more for computer engineering, a bit more for electrical engineering. Then you have your gen eds. These should be the classes that you should not worry about when scheduling your college courses. The reason being, they just don't matter. You really want to follow a requisite flow. Don't take classes that either A, don't do much for you, or B, they don't really do much for you in the following semester. They might, be a prerequisite for a class that you might take in 2 years. For example, let's go back on right here. If you look at this technical writing class right here, it goes all the way here. It goes to this lab right here. But other than that, there really isn't much to it. You have circuits right here. Circuits goes all the way to over here. And that's really all it does. You don't necessarily need to take this class. In your, first few semesters, you might want to replace that circuits class with thermodynamics or, and look at the labs too. This lab is not important. It really isn't. Or, you know, this lab right here, not, I obviously take it at the end, so that's a bit different. But just in general, you gotta follow kind of those, you know, guidelines, like, you know, calculus, differential equations, this branches off into this, you know, this, you know, you see how much prerequisites these classes unlock. It's because of the concepts and just the general knowledge that you have to know. So, for example, obviously another one is Calculus 1. You unlock Calculus 2, circuits, Physics 2, statics, material structures. Physics 1, a bit less general, statics, material structures, circuits, but now you don't unlock even more. And obviously you unlock Physics 2, but Physics 2 really isn't that important unless you're electrical engineering, which obviously changes. Chemistry, you get material structures. I mean, personally, material structures do not lead much to anything for me. I led like one class. ELA, it led to me for me it led to one lab, but for many other engineering programs it probably leads to nothing. And then you have, you know, Physics 1 and Calculus 1 both lead to statics. Let's say statics, that goes to dynamics, that goes to fluid mechanics, that goes to, you know, heat transfer, heat transfer to fluid mechanics, and just a various amount of stuff that you know. And that is the most, you know, like I said, the advanced classes and labs right here, those are really important. And these basic engineering classes lead to this. And you really need to follow that core structured pyramid. You know, math most important, then your basic engineering classes, then your advanced classes. Then you can worry a bit about, you know, other irrelevant stuff. And that's really all I have to say today. Thank you. Have a great time. Have good luck with college.